Hi everyone, Rob here, Product Engineer for enDAQ. For this Tip Tuesday, we'll be going over mean removal and why we do it. I made a recording using my S3 and I've opened the latest version of enDAQ Lab. I made a recording on my desk with the device line flat and still, and I've got the piezoelectric accelerometer selected here. But you can see there's these strange offsets. I've got the y-axis sitting at -1G, while the z and the x-axes are sitting up at +1G. You'd expect if the device is just sitting flat that everything would be sitting at 0G, but I didn't remove the mean. And unless you know enough to remove the mean using another analysis software, it's best to do it here. Piezoelectric accelerometers have a DC bias that can shift your data as the temperature changes, and that's bad. You don't want that. But it's hard to account for with the calibration that we do, so we allow our software to correct for it in post-processing. We apply a high-pass filter that removes any low-frequency vibrations, and that corrects for that DC bias and possible temperature drift. So I'm going to remove that now, and I'll show you how that affects the data. And you can see it corrects for it, and you've got all the axes sitting at 0G now, and it's a more accurate representation of what's really happening. You may have seen the option for removing rolling mean, and if the recording is longer than 15 minutes, that's typically when we recommend that you click that. It recalculates the mean at a set interval, which you can set here in your preferences, and it will correct for the mean and give you more accurate over a more accurate reading over a longer recording. So yeah, if you've got any further questions, feel free to reach out to us at enDAQ.com. And thank you for watching. Hopefully this helps you when you're analyzing your next set of data.